So thank you. Okay, I don't want to hold the show up anymore, so we should start. Yes.
Sure. Let's do it.
Thank you, panel, for your patience. I am happy to introduce you for the Structured Data in 2021 panel. We have Devon, who is the chair of the GAAD Foundation, co-founder of Diamond and Global Accessibility Awareness Day. Karen Lopez, who's a data evangelist, space enthusiast, and NASA Datanaut at InfoAdvisors. Denny Vrandečić, head of special projects at Wikimedia Foundation, and Hedden, data and knowledge engineer at Semantic Web Company. And now I will voluntarily mute myself and let you all speak. Thank you. Also, Jason is here to co-host. We'll be watching the Q&A. Thanks.
Thank you, Nancy, and welcome everybody to our panel on structured data. Before we begin, I'd like to invite all of the panelists to please just describe what it is that you do. We already had a nice little introduction, but maybe an understanding of what you do for a living. So how about we start with you, Heather? You're still muted. All right, we're going to start with Karen,
okay,
and that way, there you go. Perfect.
I didn't know you had the order different before.
Oh, sorry. Yeah, I changed the order around sometimes.
Okay. Yeah. Okay, so I'm currently employed as a data and knowledge engineer with Semantic Web Company. That's a pretty cool name. It's a vendor of software called Pool Party, which is cool in a different direction, which is for taxonomy, ontology, and knowledge graph development. And I started there only a year ago, but my career has been for over 25 years as a taxonomist. And I've worked as a taxonomist in different companies, as a taxonomy manager, and as a taxonomy consultant, and as an independent consultant. And along the way, I created an online course in developing taxonomies, which was originally offered through a college, but they discontinued it. So I offered on my own. And out of that course, I wrote more about it, and I ended up writing a book on taxonomies, which is called The Accidental Taxonomist. Now in its second edition.
Oh.
Yeah. So and so the company, yeah, I ended up working then for a vendor of taxonomy management software. I'm familiar with other ones too, but then they do ontologies as well. So I'm beginning to get into that area and knowledge graphs, and I can talk more about that.
Great. We'll get to it. I'll ask you some more questions on all of it. But first, since you mentioned ontologist, I'm going to go to Denny next, since that was his previous job. But what do you do now, Denny?
Hello. I work now for the Wikimedia Foundation, where I'm the head of special projects, which means I'm particularly heading the AppSec, Wikipedia, and Wikifunctions projects. The goal of these are to allow functions as a new form of knowledge that people can collaboratively work on, and then for AppSec Wikipedia to provide a baseline of knowledge for all of the more than 300 languages that Wikipedia supports, instead of having all the languages being independent and to grow them. I'm leading that project, having a great team of engineers and others working on it. Before that, as Joe said, I was an ontologist for Google, but I think we're going to talk about this later. And before that, I did research in the semantic web area for a decade. I founded Wikidata and was a co-founder of Semantic Media Wiki.
Thanks, Denny. And last but most certainly not least, Karen Lopez, Data Chick.
Yeah, I'm Data Chick on Twitter. So my introduction, like I never know what to call myself when you're a single person consulting services, which I've done for most of my life. And I started, very traditional enterprise thing, like programmer, and then developer, database designer. Really like the data stuff, so I've always been doing data, and I do traditional relational database design, so very structured data. But recently, like over the last few years, I've been more excited about newer technologies, no SQL, unstructured data, and how newer cloud-based technologies can help leverage all of that data. So I think I come about this because while I've had vendors, software vendors and methodology vendors as clients, I'm coming from it from an very enterprise point of view.
Great, thank you. So I'm going to dig deeper into each of your careers a little bit, but before we do that, let's set the table by asking this question. Is there a consensus on what the industry means by structured and unstructured data? And I'll go right back to you, Karen.
Absolutely no consensus at all, and you'd think there would be. So in this question, because I participate in a lot of panels, I'm also extremely overactive on social media, which might come up a few times. There's a huge range in how people use this term. And as a data architect, data modeler, we're used to labeling things and getting consensus on it, and there's none. So some of the longest debates and arguments on LinkedIn, Twitter, everything have just been drag out fights on what structured data means. So it ranges from something very narrow and physical to structured data refers to data in relational databases only. That's one extreme, to all data has structure or it wouldn't be data. So, and these are like, I kind of support both points of view. Definitely data stored in a relational database is normally very structured, but it's perfectly possible to stick all your data into a blob in SQL Server and call it a day, and it still doesn't mean it's structured. All the way to, yes, random numbers stored in a file isn't structured, but probably isn't data either, because it's just numbers stored in a file. Until we know what it means, we can't even guess what the data is. So I believe that there's no consensus and that we have all kinds of communities across the world who have a completely separate definition of structured and unstructured.
That's a great answer. However, I'm sure that Denny disagrees with you. So Denny, explain where you differ from Karen.
Well, I agree on the point that we don't have consensus. I disagree on the wideness. So I have my own working definition of what structured data is if you have an API that you can ask, this is basically the structure that you can get out of the data, which means that the very same data set can have a certain structure from one point of view, but can be unstructured from another point of view. Mm-hmm. So obviously, if I have a text, for example, which is usually the prime example of unstructured data, I can have easily still a structured access in the form of, I need the 7th letter of this text, or I need the 20th letter of this text. In this form, well, sure, it's structured data. But if you want to ask, what is this text about? Who is this text about? Is this text, who has written this text? Well, if you don't have an API for normal text for that, this means, well, this part is unstructured now. Mm-hmm. So structured data means you can actually access a specific piece of information that you're asking for. You have an API to ask for that. It's unstructured if you don't. If you need to use something like, a parser, a machine learning process over that one in order to kind of derive implicit data out of it, then it's unstructured. If you have a picture, asking which area of that is blue, kind of easy. You can get it's a structured information. You can have the same picture and try to ask, is this a picture of Queen Elizabeth II? And if you have an API to do that, well, then this information is structured. If you don't, it's not. You need to actually add that into it. You need to integrate it. You need to put it out yourself. So for me, my working definition for what is structured and unstructured data is structured data is data that is easily accessible for you through a very simple way, through an API or something like that. Unstructured data is you can't. This is the other side. And the very same data set can be structured and unstructured at the same time. It depends on what questions you ask.
The answer is it depends, but go ahead.
Yeah, totally. I agree with that. It depends. It depends what question you want to ask, whether your data set is structured to answer those questions or not. That would be my...
Before we go to Heather, do you want a rebuttal, Karen?
Well, So this is added to my list of possible answers, because at the end there you said API or other way, and
Right.
I was really going to be like, no, APIs are not required. But I get what you meant. You were using API as sort of an interface to the data and everything. And so I don't disagree with you, because my position is it depends on who you're talking to. Like, I just try to be really flexible that way and ask the question, what do you mean by structured in this conversation, so that I can work my way through it.
All right. Well, Heather, are we going to get a third perspective on this, or do you want to talk about taxonomy?
No, I'll give another perspective, but it's the or other. I liked what Denny said, that, yeah, because you can convert unstructured data to structured data by adding something, and it doesn't have to be an API. From my experience, from my point of view, you add metadata. And metadata involves taxonomies, usually.
Mm-hmm.
So you tag it. And I mean, you can also structure data if it's text, like in a format like XML too, that's all tagged in a different way. I mean, there's markup tagging, which structures data, and then there's tagging with tags and keywords and other metadata type tagging. Mm-hmm. And it's the latter that I do. And then, of course, the question is whether, then we can go down another discussion. What's the difference between data and content? Because people might say, well, a text document isn't data, that's content.
Or both.
Yeah. So
I think Denny's trying to turn it into data, but we'll get to that later when he talks about Wikidata.
Yeah. I think one of the interesting things is, a lot of times when I talk to people about what their definition is, a lot of people key right in on how is the data persisted. So in a relational database that's properly designed according to relational principles, it's persisted in a very structured way. Now, anyone can still have 10 different types of data in the same column, and they interpret it using a bunch of other columns. That's just not good relational database design to do it that way, but it happens. And that happens a lot with address line 1, address line 2, address line 3, and address line 4 that nobody uses. So people started stuffing other data in it. Like, I've come across that. So, but I don't care. Like, I don't use how the data is persisted as so a lot of people think XML, totally unstructured. And then a lot of people say, no, it has a structure because it has metadata and it's tagged. So I'm still going to fall back on, it just depends who you're talking to, what structured and unstructured means.
Fair. So where does a newbie begin? A newbie to the world of structured data, where do they begin? What tools do they use? Like, well, what's the foundation that they need to get?
Yeah. I think they should start with relational database theories and everything, and then move on to delimited files like those, and XML. Those are usually considered sort of the basic fundamentals of structured data. And then, of course, I'm biased, but that to me also involves data modeling, both logical data modeling and physical data modeling, conceptual, any of those things. And those are all really theories and things that go back 30 years or more, like back to the beginning of my career. That's the start, only because almost everything that came after that refers back to that type of structure. So any place that you would learn about, so this is a very physical question, but learn about relational data and then XML and file formats for data, that would be a good foundation. And then you can move into all the other flavors and JSON and, oh yeah, maybe you should skip XML and just go right to JSON. I don't know, because JSON is just hipster XML as far as I'm concerned.
Speaking of hipster, so you're saying people still use relational data?
Oh, heaven forbid. Yeah, that used to come up in the semantic and NoSQL conferences all the time. People predicting that relational will be gone. And I'm like, I still work with hierarchical databases, okay? Yeah. So.
All right, Heather, Denny, you want to weigh in? Either one?
No, I don't have anything to add. That sounds good to me.
Okay. Sounds like Denny's good with it too. Yes?
I'm fine with it. I would just add RDF and OWL as possibilities.
Yeah. Oh, yes, true. All the
Okay,
semantic
yeah.
stuff, RDF and OWL, for sure. And I should have mentioned that. That's what I mean came after all these other things.
Do you think our audience knows what RDF and OWL means, or does somebody want to
Yeah, I think
define it?
that's our next question, right?
All right, there you go. Heather, what is RDF and OWL?
Okay. Well, this ties into, I think, the semantic web, right?
Yeah.
Which is my company's name. But after that, because they really go with those standards. And the semantic web is not something distinct from the World Wide Web. It's like a deeper, more richer, the same, like Sir Tim Berners-Lee, who was credited with inventing the web, then went on to, Web 2.0 and the semantic web. So it's not just links, but how are things related, and much richer. And so there's the World Wide Web Consortium, often called W3C, because it's three W's, is an organization that's come up with recommendations, guidelines, standards for the semantic web. Now, originally it was intended for the public web, but as organizations, enterprises also adopted web standards internally, the HTTP and so forth for their intranets and so forth. And now we have all these web-based applications. They're now adopting semantic web standards internally too, for various reasons. But it does support more semantics. That means meaning, in the connections and the interoperability, so you can have data that's connected in different ways, whether within a large organization or across. And so one of the foundational guidelines is Resource Description Framework. That's what RDF stands for. So some of the principles or guidelines is that everything should have a unique identifier, a URI. It's like a URL, Uniform Resource Identifier, and everything is defined in triples. A triple has three parts, and this is a subject, predicate, and object. So really, there are things and relations that can be defined this way. Then you're asking about OWL. That came, so there are certain years when these came out. I'm not, I don't know off the top of my head. OWL is Web Ontology Language, and that is, as its name standard, it's not just a standard, it's a whole language for defining ontologies to be used in exchange. You can change information. Of course, I have to define what an ontology is too.
Yes. I was waiting for that.
Yeah. I should at any minute pass this over to Denny, because that's really his area of expertise. But and there are different definitions. Maybe I'll just give my definition from my taxonomist point of view, which is not necessarily. People also come to ontologies from mathematics, from computer science, even from philosophy. So I come from the point of view of knowledge organization systems. And I should mention one other while we're on semantic web that's especially relevant for taxonomies and thesauri. There's something called Simple Knowledge Organization System, abbreviated as SKOS. That's another standard from the World Wide Web Consortium. I think that came out in 2009. So that supports interoperability and machine readability of taxonomies and thesauri. But you can also link your taxonomies to ontologies as well. So an ontology, from my point of view, is like a taxonomy, is a kind of knowledge organization system. But it goes beyond a controlled vocabulary for tagging. It can be actually linked to a taxonomy. The terms in a taxonomy or concepts in a taxonomy are tagged to content, but the ontology provides a knowledge model of a domain of different kinds of relations and different classes, and they have different properties. So you're defining everything and relations. So the relations in a taxonomy are just broader, narrower. If it's a thesaurus, we have related, that's it. But in ontology, you can have any kind of relationship you want, and you can enrich it with attributes as well. So it really defines the knowledge domain. Okay, I've blabbed on long enough. Maybe has more to add to that.
Yeah, before I go to Denny to go deeper on ontologies, Karen, this is a little out of left field, but it kind of came up from Heather. The same as I don't even remember the term, but the same as term.
Yeah.
So Heather brought up URIs, and I love giving an example of how you differentiate between, for example, Michael Jackson. There's the singer, and there was Michael Jackson, the radio talk show host. So they're both related to radio somehow, but they're two very different people. So how would you use URI to differentiate the two, and how do you use same as to help to do searches?
And you're asking me this?
if you're up for it, if not, then.
So this is classic. So again, my biased view, every problem like this is a data modeling problem. I mean, the only reason I say that is data models, and I don't mean a physical database design, I mean like a logical business model, is your attempt at saying when is one occurrence of a thing the same thing as another occurrence, or is it different? So actually people are one of the hardest things to do. So I worked on a criminal justice system for one of the largest municipalities in the US, and their town councilors, their city councilors were all going to go to jail because they kept releasing the wrong people from jail. Because people don't have natural identifiers. So even things like social security numbers, they're not unique. They should be, but they're not unique.
What?
Well, so the reason they're not is our information systems have what people tell them. They don't have reality. An information system data is one layer away from reality, and we all have this miraculous belief system that our information always matches reality, and it doesn't. So, you know, there are cases where people thought they knew their social security number and they didn't. A classic story is that I think a wallet manufacturer put a sample social security card in a wallet when the social security program started. And it turned out they used the number from the CEO's secretary as a real number. And lots of people use that as their social security card. And then the SSA actually created a pamphlet once that had a sample like graphic of a card. And when that was handed to people when they got their social security numbers, and a lot of people thought that was their social security number. And then people lie, about, especially people in jail.
Shocking.
So think about people in prison and jail as the opposite of a loyalty program. They are customers trying to not be identified as a returning customer. So they fib a lot or they withhold information. So even in this criminal justice system data model, we had to rely on about 140 data points to try to identify a person. Because, and a lot of people think it's really small, like someone's first name, last name, address, and phone number is enough to know that Michael Jackson. It's not, because of people with the exact same name living at the exact same address, which happens with fathers and sons, and certain celebrities name their kids all the same name. Like, it's just, life is complicated. So the closest thing we have to a natural URI is like DNA. But try telling an enterprise that they're going to have to run DNA tests on all of their customers and keep it updated and get it done at the cash register. Like, just not going to happen. And then we have the concept of, well, DNA is extremely unique. It isn't guaranteed unique. And so there's all this. So what I understand with the URI system is people go claim one in order to say, this is me. It's not another Karen. Like, if you have a name like Lopez, there are lots of us. But that people could still, just like blockchain, people could still lie about their URI. So this is a hard problem because it involves people, not like the most common URIs I use are cloud assets. Like this storage account, this database, they all end up under the covers with URIs. And I like that, but you know, it still doesn't solve the problem of someone trying to intentionally game the system.
See, I knew you'd, as a data modeler, you would have a fantastic answer. So thank you for that.
A long one, at least.
No, it was great. All right, Denny, you're an ontologist at a little search engine startup by the name of Google. So what does an ontologist at a startup do? and please explain anything that you feel the audience might like to understand about ontologies.
Hedda actually gave already a perfect explanation of what ontology is, and Karen illustrated some of the problems that ontologies have all the time. What I find the core thing of an ontology really is that it is a document that formalizes, that writes down a shared understanding of the terms we want to use in our knowledge base, in our database, in the data that we're using. And it's not just important like exactly which language is being used for in order to describe this, but this ontology is basically saying, okay, this is a person, and we identify a person via these things. Back to Karen's example, or for example, long-standing discussion we had inside of Google is, what is a country?
That's another great one, yeah.
And it seems kind of easy, you have a list of those countries and that's it, right? Those are all the countries in. So now, but in Google, you have a lot of people asking about people like, that have lived like 100 or 200 years ago. So suddenly, we have to also have the countries where people live, where they were born. So we need to have historical countries as well. And how do historical countries relate to each other? Is the Italy of Dante Alighieri the same Italy as today? Maybe, maybe not. But if you ask for Italian authors, do you want to get Dante as an answer? Probably yes. So you have all these kind of questions like, what is a country? What is a person? What is a soundtrack? What is a song? What is a movie? And this is what ontologists try to agree on. And it's not really about, it's much less about the philosophical ideas of how are these things different and complex. It's more about, let's just find an agreement between those teams that are working on this. So it's a very human-centered job, because we need to talk with all these teams and we need to come to a common understanding. It doesn't necessarily have to be a clean definition in the end. All we have to do is to ensure that when we're interoperating, that we are like using the terms in the same way. And we need to capture this in some documents so that we can actually refer to it, and when someone new gets onboarded, that we can say, here, this is what we defined as what are countries. And this is the list, and this is what we agree on. And if you want to talk with the others at Google, well, you better keep to this. What's the language? Same problem. Some of the most fascinating discussions we had, for example, is, are birds dinosaurs? And it's like making this decision is kind of, it's also like, how can this be important? But if you have a search engine that's trying to answer questions, it actually becomes important, because suddenly you have questions like, are there any dinosaurs nearby that I can go visit? And if you tell us, oh yeah, sure, there's an aviary up there. It's like, that's not what I meant. At the same time, if you want to ask like, are birds dinosaurs? Well, we want to provide you with an answer that kind of makes sense, but how do you make this whole thing consistent? And this is really hard. Mm-hmm. So this is basically what ontologists try to do. They try to get a common understanding between the stakeholders and try to formalize this.
So you were speaking earlier to how you're doing some work on translating these things across languages, and you also mentioned Wikidata. So how do you do that? And like, can you describe what it means to cross the language barrier and turn some of these questions into data that can be used in different versions of Wikipedia?
So one of the things that we decided very early in Wikidata is that we do not want to create the ontology for the world. We don't want to be the place where we define the truth and what all these terms mean and so on. But we want to have a system that is flexible and open enough for people to enter their data with minimal ontological commitment, as we call it technically. So without necessarily committing to a grand theory of everything, but still being able to give enough information. And in Wikidata, the thing is, it's all based on, just like Wikipedia, it's all who come and go, who join and work on a specific part that interests them and so on. So, and they have the same conflicts as in Wikipedia, deciding on things like, should this be a country? Is Catalonia a country or not? Is Scotland a country or not. And they have to come to a decision in Wikidata. And the way we support that is basically by making the system flexible enough to deal with inconsistencies, to deal with contradicting data, and to be able to provide references on all of these. And this actually works pretty much the same across languages. So in Wikidata, the idea is not to connect to actual words, but to connect to the concepts behind those words, and to have Q identifiers for each of them. So we have a Q identifier for Michael Jackson, the musical artist. We have a Q identifier for Michael Jackson, the software engineer, and so on. So for all those different Michael Jacksons, we have different identifiers. And then the labels are in each of the languages. And then we can have Michael Jackson, for example, written in English for most of the languages. But if you go to Serbian, for example, we have not only written it in a Cyrillic alphabet, but also it's actually transliterated differently, and so on for the other languages. So for each of the identities, for each of the items which have a Q identifier, we would have different names, labels in different languages. And this allows us to actually provide this language in Wikidata in more than 400 languages. And we have people contributing in those languages, because you can actually even write in Wikidata in any of those languages, which means that if someone goes in and changes something in Igbo, for example, or in Japanese, it becomes immediately available in French or in Hungarian or in Chinese, because they're working on the same knowledge graph across the languages. Unlike with Wikipedia, where each of the different language Wikipedias are completely independent from each other.
So you're saying that you can go in and say the population of Klingon is 100 million, and then it'll be translated across all the other languages. And
exactly.
But does it show up on Wikipedia as well, or only in Wikidata?
More and more Wikipedias are showing the data from Wikidata and displaying it. And this is a very good thing, especially for this kind of information that you just mentioned, because the thing about data quality is that it's the same with Linus' law here. Given enough eyeballs, all errors are shallow. If you make this data very visible, it's very likely that someone will see, that doesn't make sense, this doesn't look right, and goes and edits it and corrects it again. If the data is only shown to a small handful of people, the chances of this data being not changed, not fixed, is much, much higher. So making the data visible in many, many more languages as quick as possible, particularly if it's wrong, is important, because this way we can actually get it fixed.
All right, and I'm not going to ask you about when people disagree on the data, because that's a rabbit hole, so maybe later. Heather, speaking of URIs, if you did a definition, took a URI of a definition of pool party, I think most people would think of one thing, but pool party to you probably means something else.
Yeah.
So what's your definition of pool party, or really describe, please, the product, what it does?
Yeah, okay. So as I said, the company, Semantic Web Company, it's actually based in Vienna, Austria, and I work for the US subsidiary. And I think the company was started in 2004, and the product was released in 2009 of a tool to help develop and apply taxonomies, ontologies, and then knowledge graphs according to semantic web standards. So, I mean, with ontologies, there are two different ways to actually develop them. One of them, the probably best known tool for developing ontologies is an open source tool called Protege, which is developed in some maybe biomedical lab in Stanford University. And you can build quite extensive ontologies of classes and subclasses and subs and all kinds of relationships and subproperties and so forth, all according to OWL standards. But there's some limitations when it comes to, okay, you can create a great model that way, but then when you actually want to tag and you want to have these synonyms and you want to have multilinguality, that's where taxonomies, especially SCOS-based taxonomies, are better. And another thing with SCOS is that it's very suitable for multilingual taxonomies, because you have concepts with labels, not like just terms in a thesaurus. So each concept can have one preferred label in each language, and any number of alternative labels in any of the languages. So the tool Pool Party uses SCOS as the model and standard for taxonomies and thesauri, and then OWL for ontologies, although you could even use other models as well. I mean, it's in the syntax and the RDF that's behind, you can have different prefixes. There's another word for that. If people who want to create taxonomies, it's all over. I mean, originally it was, in certainly information industries, publishing, and those who want to use it for, maybe public-facing content library type backgrounds. But now, I mean, internally, with content management systems and digital asset management systems and other records and documents and intranets, a lot of internal content's just gotten, content and data has gotten too much, and also separate in silos. And that's another thing that Pool Party does. So there's the, ontology management, there's taxonomy management, but then there's the data, right? Where's the data? Your data is in different databases or different applications. Okay. It could be in a CRM or something, or some other record repository. And then you want to integrate, well, the data's, you got information here and here and here and here, and they should be connected, and they're in separate silos. So I think you've heard this. We mentioned knowledge graph. We haven't explained what that is. Okay, so a knowledge graph is then based on not a relational database, but a graph database. And you can pull your data out of a relational database and put it into a graph database, so that there's the connections are, nodes and edges, and it doesn't have to be in a table. And then you can connect anything in any different direction. And then, of course, you can label these connections with the ontology, saying what kind of relationship it is. So knowledge graph builds on data that's in a graph database, the instance data, taxonomies for the names of concepts, the labels, what they're going to be called, and then ontology to define the relationships in the different classes. And it doesn't, actually, when you say pull the data out of the database, it's still there. I mean, it can be virtualized or whatever, but the tool Pool Party has embedded within it a graph database. We partner with the company Ontotext, which has a GraphDB as their product, but there are others, and you can connect Pool Party to another graph database that you might have as well. It has that capability. So then, in a sense, you're, virtually taking data out of different data silos and then connecting them, and then it's pretty cool. Although you don't have to use, I mean, that's kind of like the full-blown use of Pool Party to do the graph database. Others just use it for, taxonomy management on a more simpler level. But even then, that's great, because many content management systems have a very rudimentary module or feature for managing their keywords or tags. It's not very rich. It doesn't allow interoperability. It's not good for synonyms, and so forth. So
thanks. Yeah.
Explanations.
Good.
The fun fact is that that early years I used to run the Semantic Web, LA SemWeb group, and Pool Party did a demo of the product way back when. So good to see the evolution of the product.
Yeah, I'll mention one other thing. I mean, maybe even Denny would be interested. From the beginning, the Semantic Web company also likes to partner with those who are doing research in different research institutes or academic institutions, and in Europe especially, since that's where they are. So they actually have a small research team. They're just doing research, and then we can kind of come up with other cool developments as well. And they sponsor a conference called Semantics in Europe every year. That is an interesting joint academic and industry conference. It was just last week in Amsterdam, and I was there. So that was cool. I don't know when and if we'll bring that conference to the U.S. We had hoped to do it. It was scheduled in Austin, Texas in April 2020 and didn't happen, and has not been rescheduled.
Yeah.
Hopefully we'll see conferences live again. It'll be great.
But that one didn't even go virtual because it was a first time. That makes it too hard.
Yeah, definitely. So before I go to Karen, I would just like to invite the visitors to please, if you have any questions, you'll see, I think you should have it on the top right under session. It should say QA, and then you can click ask a question. So please feel free to do so, and we'll call questions as they come in. But Karen, I love all of your social media feeds. You keep talking about, you post all these NASA space things because you're a data-naut. And I was always wondering, what is a data-naut? How do you become a data-naut, and what does it entail?
Okay, so I love talking about this. I'll start it out with right now, because NASA is so busy with Artemis, commercial crew launches, all these other citizen launches and everything. The NASA Data-Naut program is currently on hiatus. But what it was before, it was, let me go back. So NASA started sponsoring exactly 10 years ago the Space Apps Challenge, which is the world's largest global hackathon that involves normally hundreds of events around the world in, like, I think over 400 locations, and I might be way low on that, in-person hackathons that take place on a weekend. This year, the 10th year, the Space Apps Challenge, if you go to that website, it's all virtual, of course, because we're still in 2021, but you can still choose to participate virtually through a local group or through a universal group, just to play on words. So I am a mentor and I help with judging this global hackathon. When that hackathon was first started, the CIO of NASA plus the woman who started it all noticed that she had lots of participants around the world that all kind of looked the same. So they weren't diverse. And the number one thing was gender diversity was an issue. And so they started NASA Data-Nauts, kind of like a learn to code thing. But the difference is the hackathon and NASA Data-Nauts is a program about working with NASA open data. So it's not just a hackathon. You have to, your solutions have to leverage NASA open data. Fast forward, so they started this program initially targeted at the people who weren't well represented in the hackathon. So I was in the alpha class for that, and then they opened it up to everyone. And the last Data-Nauts class, so it would be 50 people in an intake in a class every year, anywhere in the world, who you would attend these 30-minute lunch webinars, learn about data, learn about rocket science, because that's the application of the data, learn about ontologies, all kinds of data-driven technologies and approaches, and then go off together and do a project together as a group with the open data. So that's all really exciting. Like I said, so it's all volunteer. I don't work for NASA.
You are a rocket scientist.
I'm a rocket surgeon. No, I'm not a rocket scientist. So I am wearing rocket science dress though, but today. But the reason I'm happy you asked is there's still time to register for the Space Apps Challenge. And because we're in our 10th year, there's a theme on 10. And you don't have to code to participate. There are challenges around art, so it's very STEAM based, or you can just create an idea for an app. So it's really about the pitch, just like any other hackathon. The key is now the Space Apps Challenge is open to other space agencies, like the Canadian Space Agency, very near and dear to my heart, but the Japanese Space Agency and the European Space Agencies. So you get to work with anyone's open data. And I just so enjoy this. Like, it's especially a good way to bring kids or grandkids together to work on a project. There's also like robot challenges. So nice. It's not just coding, but even the art has to be driven with open data. So
speaking of diversity, are you familiar with Astro Access?
I'm not. Tell me about that.
They're doing accessibility in space.
Excellent.
So we're talking about diversity. Unfortunately, a lot of diversity initiatives forget about people with disabilities.
Yes.
So what they're doing is there's a launch, I think, coming up in a month. I think it's October 17th, where people with disabilities are given the opportunity to go up into space. They're doing the preparations where, you know, how you have those flights that rotate to simulate zero gravity. Yeah.
Oh, those. Yeah.
Yeah. So that's just in preparation for it, but there's a bunch of ambassadors, super interesting people, and had a great call with them. Made my year, really.
That's excellent, because most space agencies don't have provisions for people with disabilities, and even being too tall or too short can exclude you from participating in official space agency stuff. However, the European Space Agency recently announced that they're going to start accepting applications for actual astronauts from people who have certain types of disabilities that will still work well in space, or that they can accommodate easily. So to me, that was a big difference.
Yeah,
that lots of people were excluded.
Yeah, that's great. And Nancy posted the link in the Q&A at astroaccess.org. I don't know if everybody can see that or not, but yeah, astroaccess.org. Nice. So speaking of accessibility, and there's also spaceappschallenge.org was also posted.
Yeah. So, go sign up.
Yeah, absolutely. So Denny, speaking of accessibility, how does some of the work that folks are doing in structured data, perhaps some of the work you're doing with Wikipedia, how does that empower, or how can that be used to make accessibility better, or improve the accessibility, whether it's of Wikipedia or just in general?
In general, the Wikipedia projects and the other projects by the Wikimedia Foundation strive to be fully accessible, not only for reading the content, but also for contributing to the content. We make sure that we lower the barriers as far as possible, that we are accessible easily for screen readers, that we can be edited with alternative browsers that might be helpful for people with certain disabilities to work with the content, to read the content and so on. Nevertheless, one of the things that we are not particularly good at is that the reading level of Wikipedia is in general quite high. You need to be okay with sometimes pretty long sentences, pretty complicated sentences with a lot of terminology and so on. Because, unsurprising, it's an encyclopedia. It's written in the style of an encyclopedia, and therefore it uses language that's rather dense, that uses a lot of technical terms and so on, which are in turn often explained, but clicking through 20, 30 articles just in order to understand one article is not necessarily the most helpful thing. So one of the things I would love for AppSec Wikipedia and Wikifunctions to make easier is actually the ability to represent the content in the natural, neutral way, independent of a specific natural language, which would also allow us to, for example, expand the content in some cases. And for example, say, okay, instead of using a technical term here, let's use the explanation around it. Instead of, just to give one example that I like using, I have a 7-year-old daughter, and sometimes we're outside and we look at a flower and say, for example, a daisy. And then I open the article for daisies, just like to give a bit of background information because it's fun and teachable. But the thing is, if I read the article about daisies in Wikipedia, I don't understand that much there. And I have a PhD, granted, not in biology, but still, I don't understand what it's written there. And it's like, I mean, if I can't understand it, I definitely can't just read it out to my daughter. I mean, I don't even understand how this flower is described. It's just a daisy. Well, it would be great if we could adapt this content to different readers, to make it more accessible. I'm not saying to change the content. I'm not saying that people with different belief systems should get different content. That's not the point. It's really about making the content more accessible, making it easier to understand, to adapt to the reading patterns of certain readers, to use their background knowledge and to make it so that we can research. Another example, math articles in Wikipedia. I often have a hard time reading them, and I need to click through. And often, just because I don't have the definition of what a ring is or what a group is right in my head or whatever. And it would be just easier to add those into the article, make it easily accessible. So this is one of the things that we would like to improve the wiki functions, and that we're hoping for will happen within the next few years.
Interesting. It kind of makes me think of an idea. I'm curious what your thoughts would be. So there's WCAG is the Web Content Accessibility Guidelines. And when it comes to cognitive impairment, there's different levels. So WCAG level A is really the basic accessibility features. WCAG level AA is what most websites and apps are going to try to hit AA. And then AAA includes different features, including for people that have cognitive disabilities. So if you're doing a scientific journal, you're probably not going to go for the AAA. You'll probably go for the AA. But if you are, let's say, a hospital where you have all kinds of patients, including folks that before my mom passed, you had dementia, you have people at all levels on the cognitive scale. And so therefore, what's interesting about Wikipedia is in some cases, you're going to have a scientific page, and there you don't necessarily need AAA, but then sometimes you might have something that's a page that's important to reach a very wide audience. And perhaps there could be one way of showing that this page, the reading level of that page, and maybe even target that certain types of pages try and get to a AAA level. Do you think that's something that could be brought up as a proposal to Wikipedia? Would that be of interest to the Wikipedia Foundation?
So yes, but I think this is more important to the Wikipedia communities than for the foundation, because they are in control of the content. Whereas the Wikimedia Foundation can make sure that the software showing Wikipedia and so on fulfills all accessibility requirements, this only takes us to the AA level, as in this framework you just described, because the content itself wouldn't be touched by that, right? And so having in place guidelines for writing the content of Wikipedia and so on, that's something that the communities would need to take up. And making them more aware of this is certainly something that is, I think, very worthwhile. I find it difficult to decide in advance which kind of articles should be AAA, which should be AA, and so on, because suddenly something like coronavirus, which might be a very technical term for decades, becomes something that's super important for a lot of people, and we can either obviously switch then the designation and say, okay, we now need a version of that, and which is written in AAA, or we need to rewrite this or something like this, but I think it's something important to keep those things in mind, because our mission is really to make knowledge accessible and shared with every human on the planet. And keeping people out because of cognitive disabilities or other disabilities would certainly not viable with our mission.
Yeah, well, thanks. All right, Heather, let's go back to the structured, unstructured question. What do you do when you're faced with a combination of both?
Oh, well, yeah, then you add structure to the unstructured. Like I said,
How do you do that?
Yeah, with the metadata. Actually, I thought I would still comment on the last topic too,
Sure.
a little bit, because it's what Denny said, kind of, different names and labels of things. That's also, I mean, it's not exactly accessibility, but, accommodating different audiences. So the labels for the concepts in a taxonomy should reflect the language of the users, not just, linguistic language, but their, level of how technical it is or not. So something that's medical, if it's aimed at patients, isn't the same as when it's aimed at healthcare providers. They would have completely different names for many, many different things. What gets complicated if you want to have the same, you have the same content or the same taxonomy, and you're trying to serve different audiences. So just has different taxonomy concepts, can have different names in different, natural languages. They can, we may say English, Spanish, French, German. They can also have different labels even within a language, like English, to suit the different audiences. So I just wanted to mention that.
Yeah, I was thinking about that when you were talking, because I was thinking of words like jumper and spanner, and like jumper in UK English.
Oh, okay. Well, that's another thing. Different variants within one language. Yeah,
exactly. And I'm thinking of all these layers to metadata and understanding that a jumper in America and Canada, we're weird because we're kind of an overlay of both. Like if you say jumper here, people would probably know you mean sweater, but a lot of places in the US, if you said jumper, they'd think jumper cables and not a sweater, right? So.
Right, or somebody that's ready to jump off a bridge.
Yeah,
right.
Something like that, yeah. Like I find those nuances really fascinating because most people don't think about them. Mm-hmm. And it's especially true within an enterprise, where an enterprise itself has its own jargon and lingo and everything. And then my favorite one is growing up in Indiana. This has fallen out of place, but in Indiana, a mango is like a green or red pepper. So you'd get a pizza with mango, but to the rest of the world, that meant fruit, right? So.
Wow. Cool. So now the next little bit, I'm just going to open to everybody to feel free to speak. Where I was going with the unstructured and structured data, what I was really thinking about is, imagine you're building a search engine, and how do you take this blob of data from the internet? Since the semantic web, you don't have everybody making structured data, so you have to take unstructured data, turn it into structured data, and hopefully you'll get some folks creating structured data on their page. So how do you take all of this and turn this into data that powers search? And that's part one. Part two of the question is, whatever happened to federated search? So open to the floor.
All right. I guess you were asking me before. I'll start with one. Well, yeah, it's quite ambitious if you're going to tag the web. Usually people don't. That's good. But as I said, you add metadata to unstructured data and it becomes structured. But if there's a whole, there's so much, and there's a limit to how far you can go with that. But tagging for what the content is about. I mean, that's really what people want to know. What is this about? And then that can be done with automated methods. I mean, manual is great. That's actually how I got into this whole field. I was a manual indexer. So there are technologies based on natural language processing and machine learning for auto tagging. And that what do you tag with? You tag with concepts that are in a controlled vocabulary, a taxonomy. A taxonomy is a controlled vocabulary that has hierarchical structure, basically. And ideally enriched with all those synonyms or variants. So this way, somebody puts something in a search box, and that the search string doesn't match anything in the text, but it's there anyway because they thought of a different name than what's in the text. But behind it, there's a controlled vocabulary with matching the synonyms. Some of them can be pretty simple. The simplest kind of controlled vocabulary we call a synonym ring or a search thesaurus. It doesn't have the hierarchy of a taxonomy. It doesn't need to. And there isn't any preferred label that's displayed. Nothing's displayed to the users. It's a kind of under the hood in a certain way, but they don't need to know that. There's no need to have something. If there's ever any display, like browse these categories, then you have to make a decision what's going to be the preferred displayed label for the concept. But otherwise, a synonym ring or thesaurus and controlled vocabulary, and of course, the natural language processing that does the stemming of singular and plural and other lexical variants of words as well. But it's important that it's understood that these are not just words, they're terms. They can be two together. Natural language processing would then try to find concepts and not just words, looking for co-occurrences of words that are often together that represents a concept, and frequency and relevancy. So I'll leave it at that for now and see what someone else has to say.
This leads exactly to how you would connect it with a search engine, because your knowledge graph, where you have those concepts defined, is basically the thing that you use for indexing the unstructured data, that you use for indexing the documents on the web and so on, so that you can, if you have a well-designed system, actually search the web for everything that is tagged with Michael Jackson, and you know the different Michael Jacksons, right? That you can, and how else do you actually search for that? If you have one Michael Jackson, just as an example, who is much more popular than the other Michael Jacksons, it's super hard to find those other Michael Jacksons, right?
Yeah.
But if you have a knowledge graph, for example, that represents those different entities, and you use not the word Michael Jackson, not the string M-I-C-H and so on as your tag, but you use this unique identifier that you have for those different people, then you can access and get documents that are about the other people. You can immediately say, you've been searching for Michael Jackson, you're probably looking for this one. Okay, this will be covering 95% of the searches. But for the other 5%, you can put in the side tag and say, maybe you did mean one of these here. And then you just click on it and you get all those other documents. And indexing not by strings, but by things. Strings, not things. This was the big tagline for the Google Knowledge Graph. Indexing by entities, not just by strings, can give you exactly this power. And everybody thinks about the knowledge graph in Google, about the Google Knowledge Graph being the thing that answers questions, and it shows you this nice box on the side. And that's a cool feature. That's really nice, that's lovely. But the real power is in this indexing of the actual web, making the search so much better for everyone.
How about the semantic web, federated search, hooking up all these RDF databases? What happened to it?
On Wikidata, we're actually using it pretty much. So Wikidata is connected with a Sparkle endpoint that allows you to query Wikidata and display data from it. But you also can use it in a federated search manner. So to give you just one example.
Hey, can I ask you an example? Maybe you can use that. If not, go ahead with yours. Yeah. I really want to get at data on cases around coronavirus, right? And it just hit me now that I didn't try Wikidata. Could you use that as an example? Or if not, if that messes it up, then go ahead with the one you were going to go with.
You could actually, and we have a lot of data about the coronavirus inside of Wikidata. In fact, particularly the volunteers in India have used Wikidata to store the data about cases, about caseload in different provinces and places in India, in order to make it accessible in the different language versions of Wikipedia that are relevant for the Indian subcontinent. So we would store the data about the cases only in one place in Wikidata, but make it accessible in about half a dozen languages in Wikipedia. So we have a lot of this data in Wikidata, but we're not using really the federated mechanism for that. We're just actually storing it all in Wikidata. One example for federation that I found pretty convincing is that you actually can use OpenStreetMaps as a source of federation. So also their data is available in a Sparkle endpoint. You can use the Wikidata data in a Sparkle endpoint. And because we'll never cover what OpenStreetMaps have, so OpenStreetMaps will always remain a much more comprehensive data sets for geographical data. And we don't want just to copy everything. That would not be right, because map data is very different from the data that we have in Wikidata.
And it changes every day.
Yeah. So, but we have the federation between those two, and what you can do is actually you can ask, for example, for queries which span those two databases. To give one example, you can ask for which banks belong to certain networks of banks, and then you can go to OpenStreetMap and ask which ATMs belong to those banks, and then suddenly you can ask actually to all the ATMs belonging to a certain network of banks. OpenStreetMap doesn't know the banks belong to this network and so on, but in Wikidata doesn't know where ATMs are. We don't have an entry for every single ATM in the world. But you can then query those things together and then get the geocoordinates which are relevant for your banking network and put them on a map directly rendered out of Broken Obsidian, and all of this within a single Sparkle query without having to write a single line of code. You just have this one query, and you get immediately an up-to-date and interactive map visualization out of the thing without having to write anything, like any code. It's just one query. And I find this a pretty powerful implementation of federated queries. And you can do this with a lot of different other federation sources. We have federating with a number of biomedical records and many other things. So you can basically, whenever you need to go into something into much more detail than Wikidata can provide, you can just federate it out to those places. And I know it didn't really fulfill the original blue-eyed promises of the semantic web and so on, but it is actually there. It works, and it is in a state where it's actually useful and can be used.
Yeah, I've definitely used it, and I need to revisit it now. But so just one last follow-up on that. If there's a bank robber listening and they want to get a list of ATMs, what's the URL at Wikidata to get that information?
Query.wikidata.org.
Okay, thank you. Karen, did you want to add anything to that?
Yeah, just a slight snarky thing. Like, that question just made me tired. Because, like, I think about how hard it is to tackle very similar problems just within one enterprise. Like, talk about a job and a project that just never ends, and you're always 1% done, no matter how hard you work. That's how I feel about them. I mean, there's a good reason I don't work in this area, because to me, it's just such a, like it's as big as the universe. The internet is, in my mind, infinite in effect, right? From a theory point of view. So the thought of even indexing it all sounds almost impossible to me, and let alone doing entity extraction and tagging it and trying to sort out tone and everything. I know that we have these tools that really help with this. And eventually someone comes up with a meme that says, is this a Chihuahua or a blueberry muffin? If you've seen that graphic, it's really cute. And you know that I'm used to working in a transactional database world where the answer always has to be right at all times, like your bank account total. And it's hard for me to get my head around these other problems that are expanding at a much faster rate than the universe is expanding right now. And it's just like, I just admire people who are working on these problems, because I just feel like someone will create a new way either for it not to work with your tools, or the thing that I worry about, that's kind of a question back to people, is what do we do about all the people that game the tools and the stuff? Like people who intentionally tag data wrong and release it into the world, or misinformation. I mean, that's in the news a lot now, is that we keep developing these internet technologies that pretty much assume good actors everywhere. And I'm not even talking about hackers. I'm talking about people who go in and, you know, write whole websites about stuff where they're just hoaxing people, like maybe even The Onion. It's comedy or parody, but as it makes its way through the systems, it gets almost treated as fact by either people who are low information about the subject, or because like the big thing is Facebook, not censoring, but Facebook governance, where a meme I posted that is totally 100% parody had to be taken down because it wasn't true. And of course it wasn't true. Like, to me, the humor of it was so strong that now for the first time in my life, I've got like this X against me because I posted this information about the Dallas Cowboy cheerleaders.
Oh, wow. Wow.
I mean, so how do we deal with people intentionally trying to game all of these taxonomies or ontologies or the automated tools? Like, that's my big worry about, like, where can it go wrong? Because yet again, we are hoping that everyone's a good actor.
Yeah, that's for sure a big problem. Go ahead, Denny.
Well, in the Wikipedia community, we certainly don't assume that every contributor is an actor. So the question is, why does Wikipedia deal comparably better with this kind of misinformation than, for example, Facebook or Twitter does, even though Facebook and Twitter have so much more money available and so much more resources than the Wikipedia communities? So the problem is not necessarily that big systems are problematic. It's the type of which governance they have and which kind of incentives do they have. Is Facebook, is Twitter really interested in the truth, or are they more interested in engagement, for example? Is Wikipedia more interested in getting a collaborative understanding of the world and or is it more interesting in engagement with its content? And I think this kind of questions often lead to decisions downwards where we can have very problematic outcomes. Wikipedia is by no means immune to those systems, and it's a big it's a thing that we should really be thankful to the community for, to be able to actually deal with these situations. We know that government actors have been trying to infiltrate Wikipedia, and in some places have succeeded. We know that there are other groups that have been trying to infiltrate it and have succeeded. But it rarely has been on a scale as we have seen with other applications that have been used by so many people. And I'm not sure that, I'm not sure which kind of incentives or maybe regulations would be necessary in order to ensure that misinformation and other can be kept in track. If we just leave it to the tech companies or the tech organizations to decide on that, we will have to live in a world where the incentives that those companies have might be not always aligned with what is good for society overall.
Yeah,
that's for sure. So this whole conversation has been fantastic. I didn't get to all of my topics, but I think it's time for us to wrap up. So I would like to invite each of you to provide your final thoughts here. So who would like to begin?
Oh, I guess I can. I'm the one that's not muted, and I didn't speak as recently. Yeah, I think, and it does actually kind of that very last question I didn't answer about what happened to federated search, and especially within the enterprise. And I do think that knowledge graphs have provided a solution that does what federated search does and more. So I think going forward, that's a lot. I mean, knowledge graphs can bring together the structured and the unstructured data. They can bring together data and content. And I felt, with my background, taxonomies are mostly for tagging content, where ontologies, they can apply to data too, specific instance data that could be, just data as a cell that was originally in a relational database. And then bringing them together, taxonomies and ontologies, into a knowledge graph, we have access to all of this, structured data, unstructured data, structured content, unstructured content, at least within the enterprise. I mean, forget the whole World Wide Web out there. That's we're not going to index the web in the same way. I mean, you don't apply a taxonomy to the whole web. I mean, you can use certain technologies of language and algorithms to get to a certain point, but when people go to the web, they're just looking for some information about something, not everything. But inside an enterprise, you might want all the information on something. So it has to be, accurate information, data. Well, information is built on data, and so forth.
Thanks, Heather. Who wants to go next?
I can go. And I'll leave the wrap up to Denny, because mine's more about the theory of data, the philosophy of data. Is that when I work with developers and DBAs and people inside an enterprise, they think the hardest data problems are like calculating double declining balance year over year, some sort of calculation. And in my multi-decades of experience, the hardest thing is, what is a customer? How do we define a person's name? How do we define how it's spelled? Like I see Denny here, like I do, has all these special weird things going on with the letters of his name. And we all know computers hate that because they were all designed as if those didn't exist. And transliterations and knowing that Karen with a different email address is the same Karen, but it was actually another Karen before because my name changed and I ended up with the same email address. Like, the hardest things to understand are people, places, things, and events at the fundamental level, because people think that part of the world is simple, and it's much more complex than that. That's why a criminal justice system has to keep track of body parts and scars, marks, and tattoos to identify a person, not just their first name, their last name, their address, and their phone number. So the hard part of structured versus unstructured is understanding that if we don't understand the data literacy rules, we can't do all this other stuff because we have to make accommodations for people who have no first name or no last name. And it literally happens in the world. So what we all think is the easy part is the hard part, and double declining balance year over year is easier because it's definable.
That's great. And I'm laughing because I have taken my contacts database, the various ones I have, LinkedIn, you know, the iOS and all this stuff, and I mudge the data constantly. And one of the names that keeps messing it up is you, Denny, because your last name has the accents and all that stuff. And so I see your last name in different ways. So this is really hilarious.
He's brave. He's brave to spell his name correctly in an online world.
Yes. And so, Denny, you have the last word.
I always do the thing that I spell it really correctly, and it's always fun to come to a conference and get your name tag being ending in 2 boxes, basically. Had this happen quite frequently, but I don't mind. I'll keep pushing for it because I mean this is just about Unicode, and this should be something easy. But you know, Unicode is like the foundation of structured data in many ways, and we still struggle with it, and we still have a lot of tools that can't deal with it. So on the one side, we are pushing to expand what we can do with data. We're pushing this idea of having data much more on the web, on pushing this whole semantic web idea, which yet still is unfulfilled compared to what Tim Berners-Lee's original vision was. But on the other side, it has achieved so much in the last few years as well. There's so big applications of this data everywhere. It's really it's amazing to see that. And sure, all the way down this track, there will be problems, there will be issues and so on, but I think we should be also pushing further. We should be pushing more. We should be pushing into reaching and being helpful for more people. We should be pushing into getting new mechanisms to also work with the data, to make it more accessible, to make it more usable. Then the next thing that we are aiming for with wiki functions is to bring functions into the whole mix, so that you cannot only access data, but you can actually take data from different places and do something with it, do calculations over it, make answer questions. And we are already in a world where our digital assistants are answering us more and more questions, often based on the data from linked data sources, from GLAM institutions, from Wikidata and other places. And we are answering more and more questions, but we're currently in a world where we are restricted in what kind of questions can be answered by the decisions of the tech companies and what they implement, by the decisions of what the engineers do and what they work with. We can't say, something that we really care about would be this kind of question. Let's get this answer too. I can't get this into my Alexa or Siri or Google Assistant in order to get an answer. I can't add this simply. And with wiki functions, we want to provide a place where we can actually add this kind of question answering systems where you get with high confidence. On the one side, what we have in Wikipedia is to provide you with knowledge. But being able to answer questions with a function actually enables us to answer questions no one has ever asked before, and with a high confidence get an answer that is correct. And this is pretty amazing. This is a superpower, really. And this is what we want to open on top of the data that we have now on the web. On top of the data that is available to us, we can actually give a whole level of more questions being answered. And so we want to work with the structured data that is there. We want to add more structure to unstructured data. It's something also you can do with functions, and bring this all together in a way that is actually usable by as many people as possible, and not just by the big tech companies of the world.
That's great, Denny. And there's a Raspberry Pi hack where you can do Alexa, instead of it listening to you all the time and sending it out to the cloud, you can decide when you're speaking to that Raspberry Pi to pull it out to Alexa, but it'll be great to have an interface to Wikidata through your Raspberry Pi. So I'd love to see that. And I think, Karen, you wanted to add something. I saw you get excited and animated. So did you want to add something to that before we wrap?
Not a whole lot, just that you kept waking up all my assistants. And you're supposed to say, that shall not be named. You probably woke up assistants everywhere on the planet and everyone who's going to listen to this recording. But I loved what you had to say about it.
Thank you. Thank you to all the panelists. You were great. I can't wait to see all of you in person when we're back to that world. So
thank you very much, Joe and Heather and Karen and Denny. It was really great. I learned so much. I just wanted to alert the audience that there is a session evaluation feedback form in the chat that Jason has kindly posted. So please take some time to give us feedback on the session. And yes, I'm really looking forward to this being an in-person event again in the future. But I will follow you all on LinkedIn, and then I'm very grateful to have met you. Have a great afternoon. Enjoy the rest of the conference. Thanks, everyone.
Bye.
Bye.